Okay, so in this lesson we are going to discuss the mechanism for nucleophilic addition. This reaction is for both aldehydes and ketones. So we want to define what is a nucleophile. So the word nucleophile is made up of two words, nucleo and the word phile. Nucleo from the word nucleus. So the nucleus is positively charged, so it means positive charge. Then phile means loving. So for a species to be able to be attracted by a positively charged center, so it means the nucleophile is negatively charged. So the nucleophile is negatively charged, or it is electron rich. So by definition, nucleophile is an electron rich species seeking electron deficient center. So examples of nucleophiles, e.g. cyanide. Then another word is addition. So an addition reaction, it involves a reaction which results in an increase in the degree of saturation. So we are starting with a compound with many multiple bonds, then at the end you are going to have single bonds. Alright, so this reaction, we are going to use reagents. So the reagents for this reaction, we are going to use hydrogen cyanide. Then condition, we are going to use an alkaline solution such as e.g. So we need an alkaline solution, or presence of cyanide ions, and these ones, they act as catalysts. So these ones act as a catalyst, and we heat under reflux. So why do we use hydrogen cyanide? Why do we use source of cyanide ions or an alkali? So the reason is because hydrogen cyanide is a weak acid. So hydrogen cyanide is a weak acid, so it partially dissociates in water. So the concentration of the nucleophile, so the cyanide is our nucleophile. So since hydrogen cyanide is a weak acid, the concentration of the cyanide will be low. So in order to increase the concentration of the cyanide in the nucleophile, we can use potassium cyanide or sodium cyanide. So this fully dissociates, giving us potassium ion plus cyanide ion. Or we can use an alkali. So let's say we have got the reaction hydrogen cyanide plus H2O Alright, so by adding an alkali, so alkali sodium hydroxide provide hydroxide ions, so it reacts with hydroxonium ion or H plus ions. So this reaction, the second reaction, reduces the concentration of the second reaction reduce the concentration of hydrogen ion, thereby shifting the equilibrium position to the right, increasing the concentration of the nucleophile. So it reduces the concentration of hydrogen ions. So according to Le-Chatelier's principle, it will shift the equilibrium position to the right, increasing the concentration of the nucleophile hydrogen cyanide. So we are now proceeding to the mechanism. So we now have the cyanides. The first reaction, we need to have the cyanide. Then the carbon is electron deficient. So cyanide attack the electron deficient. So this reaction is slow. That's our rate determining step. This is because it involves bond breaking. So bond breaking is endothermic. So we are going to have the intermediate. Then this stage, so let's say we are using we are under alkaline condition. So in the presence, so let's say we are using alkaline, under alkaline condition. So we get the proton from water. So this hydrogen is electron deficient and oxygen is more electronegative. So this reaction is fast. Then we are going to get OH plus. So we have produced the hydroxide, so catalyst regenerated. So in the case we are using potassium cyanide as a catalyst. So in the case of having cyanide as a catalyst, in the case of, for example, we've used potassium cyanide. So the first step is the same, but the second step, so we are going to have R. So since hydrogen cyanide is a weak acid, so we are going to have plenty of hydrogen cyanide undissociated. So we get a proton from undissociated hydrogen cyanide. So this becomes the first step. plus cyanide ion. And again, catalyst is, so this is a catalyst, and so this is also a catalyst. So catalyst regenerated. In this case, catalyst regenerated. So in the first reaction, you can either use this reaction. If you are under alkaline, we can use this reaction. Under acidic condition, in the presence of potassium cyanide, you can use this equation as our first step, so that you can regenerate the catalyst. So we can also have, like, we can combine these two equations. So we can get HCN, we can say HCN plus hydroxide, then we get, so that's the overall reaction, then you get cyanide plus H2, or the reaction is also acceptable. Then lastly, we need to be able to draw the energy profile for this reaction. So we have got two steps, the slower and the faster. So now, so the energy profile will look like this. So to look like this. So the reaction is, it is exon, so we have got it like R plus HCN. Then we've got the product R OH R CN. Then here we've got an intermediate. So the intermediate was R, then, so this is our NH. Reaction. I thank you.